Hello, welcome back to Cinderella Math. Today we're going to be doing some calculus. It's going to be limits with radicals or roots, and I would call these difficult. There's all sorts of limits you can do. A lot of them do involve radicals, but I would call these on the difficult side. This is for a Calculus 1 level. If you're in a very difficult pre-calc, you could maybe see it there, but I would say this is straight Calculus 1. I have 3 examples for you today. All right, example 1. We want the limit. I always do cursive so that my L's don't look like 1s of x as it approaches 4 of the function 4 minus x all over 2 minus root x. All right, that doesn't look hard at the jump. Well, first of all, you would try to plug in 4, but that would leave you with a denominator of 0. We can't divide by 0. So your immediate reaction should be to multiply by the conjugate of the bottom. So that's 2 plus root x. And your immediate reaction would be right. And we're going to go ahead and multiply on the top and bottom, but top first. 4 times 2, so 8. 4 times root x, so 4 root x. Under, this would be minus 2x. And under, this would be negative x root x. Okay. And then on the bottom, now this one should be prettier. 2 times 2, so 4. Positive 2 root x. Negative 2 root x. And negative root x squared, which will just bust out and be minus x. Okay, the whole point of the conjugate is to get the root off the bottom. These guys here, positive 2 root x minus 2 root x will cancel. And now we are looking at 8 plus 4 root x minus 2x minus x root x all over 4 minus x. So usually now we could just plug this in and we can't because the denominator would still be 0. So this is where I kept getting stuck. I was like, I don't know what to do from here to get this thing to work. So after a lot of trial and error, if you look at the top, that is a 4-piece situation there. Let's try to factor it by grouping. So for the first 2 in the parenthesis and the back 2 in a parenthesis. And now take the GCF of this group, which would be 4. That would leave 2 plus root x. And then the GCF of this group would be negative x, which would leave 2. And then that was negative, so negative divide negative, so plus root x. So the grouping did work. Because to get grouping to work, this guy needs to match this, which it does. So now to finish off the grouping, we factor out that common factor of 2 plus root x. So this is gone, and that would leave 4 minus x, and it's still all over 4 minus x. Now we're in business. We can actually cancel the 4 minus x, and we can finally take the limit as x approaches 4, plug that in. That would be 2 plus root 4, 2 plus 2, 4. So the trick was seeing that that top guy was a 4-parter, and then you could get it by factoring, by grouping. That really tricked me up. I got there eventually. I was annoyed. All right, number 2. This is the limit as h goes to 0. We have the root of 8 times a plus h, all in the root, minus the root of 8a, all over h. Okay, so again, probably gut reaction is to go ahead and do the conjugate, so we are. So that would be 8a plus h, all in the root, plus root 8a, top and bottom. On the bottom, I would just do that first. You're just going to have h times that whole conjugate. Okay, on the top, root times root. So he's going to bust out, right? That's really that whole thing squared. So that's going to come out of the root. So that's just going to be a regular 8a plus h. Okay. And then root times root. So that'll be positive root 8a plus h times root 8a. And then under will be negative root 8a plus h times root 8a. And then under positive times negative, so negative, and then that would just bust out, right? Because that's root 8a squared. So that's just going to be 8a. Okay, and again, the whole point of the conjugate, the middle garbage should cancel. So this right here is positive, blah, 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 minus, blah, 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 blah. So right there in the middle, it does cancel. We can distribute this 8 to be 8a plus 8h, and then we still have minus 8a. So that's gone. Cancel there. And then we still have the entire bottom. Okay, but look, top and bottom, the h can cancel himself. So we are at limit as h approaches 0 of 8 over the square root of 8a plus h plus the root 8a. But h is going to 0. So this is really just gone. So we have 8 over root 8a plus root 8a. These both have a coefficient of 1, right? So that can be 8 over 2 root 8a, combined like terms. But 8 divided 2, that can just be 4 over root 8a, right? But we're not allowed to have a root on the bottom. So let's go ahead and multiply by root 8a to get that off the bottom. That would just leave, this bottom is really root 8a squared, so that would bust out and be 8a. And then 4 root 8a. Oh my gosh, I'm going to have to white out and do some at the top. Sorry. I'm at the green. I'm going to bring the green to the top left. So 4 root 8a all over 8a. But 4/8 is a half. So we could have root 8a over 2a, but then 8 can simplify, right? Bring 8 to the side. That's 4 times 2. 2 times 2, partner. That's how I do my roots. You can do it however you want. So 2 would be on the outside, and a root 2a would be on the inside, all over 2a, and this would cancel. So final answer, root 2a over a. The actual calculus of that, just doing the conjugate and then taking the limit was not the hard part. The algebra is what'll get you on that one. So watch that back a couple times if you need to. All right. And the question on that one did, I think it said evaluate the limit in terms of a. So it's completely fine that we have an a in the answer. We don't know what a is. All right. And then I have a last one for you. This is number 3. Limit. This has, well, never mind. I'm going to say X. The actual problem has a T that my student was working on, but I don't like T's because they look like pluses. So I'm going to say X goes to 0. 7 over X root 49 plus X minus 1 over X. Okay, so that's annoying. We need a common denominator. If we're going to subtract or add fractions, we need a common denominator. He has an X, he has an X. So this right side is missing the root. And then, of course, we have to be fair and give it to the top. So now we can just make this one big fraction, 7 minus, you can ghost the 1, right? He's not super important. And then you still have the common denominator. Okay, there we are. Now we're going to do the conjugate. I'm going to actually come down to the next row. I'm in blue on the second row of work. So we're going to do the conjugate of the top. So multiplying by 7 plus the root, top and bottom. All right. 7 times 7, so 49. 7 times positive root, so that'd be 7 root 49 plus x. Under, so this is negative, so negative 7 root. And then positive times negative, so negative, and that would just bust out, right? Because that's really root 49 plus x twice. So minus, put in parentheses, 49 plus x. So because it's subtract that whole quantity. All right, we'll mess with that in a second. On the bottom, you would just distribute this. So that would be 7x with the root. And then that would be, let me make sure I'm getting this right. Sorry, one second. There, I'm looking at the wrong piece of paper here. Okay. Okay, so now I'm doing, I'm on the bottom, and I'm doing this quantity times this quantity. So you'd have an x on the outside, and then you have this root times this root. So it would just bust out. Yes? Yes. Technically, I'm trying to think we should distribute. No, let's not. Okay, on the top, we did the conjugate of the top, so we should have some canceling, and we do. Set positive 7 root blah 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 minus 7 root blah blah blah. So right there in the middle, as we suspected, this should cancel. Distribute this negative. So on top, we have 49 minus x. This will cancel. So the top is down to negative x. The bottom, we have a two piece of information here. 7x with the root plus, let me fix the bottom. Sorry, that's sloppy. Let me fix the bottom here. So after distributing on the bottom, we have 7x with the root, and then plus x with the root busted out. Now we could distribute the x, but I would not recommend it because looking on the bottom, we could pull out, this is one chunk, this is one chunk. They have a GCF, greatest common factor of x, leaving 7 with the root plus just the parenthesis garbage. You could technically take that out of parentheses. Okay, so now we've pulled the GCF and you can cancel this x. So we are at negative 1 over 7 with the root plus 49 plus x. And this whole time I just haven't been writing it. It's been limit as x goes to 0. So everywhere we see x, he's 0, he's 0. I'm going to come over here. I'm in the brown. So negative 1 over 7 root 49 plus 49. So we have negative 1 over 7 times 7 plus 49. Negative 1 over 49 plus 49. Negative 1 over 98. Answer. That is hard. Again, feel free to watch that a couple times. Sorry if my work got a little sloppy there. I need to learn to write smaller. Okay, that is calculus difficult. Limits with radicals. All of those did require the conjugate, so that is a crucial skill there. So make sure you're practicing that. If you're in Calculus 1, you should feel comfortable using that conjugate. Just be careful. Take your time when you're foiling or distributing. Because I did, when I was working this on paper, I messed up that bottom, the distributing of the denominator several times, and that messed me up for good. And again, the trick to that was on the bottom here, see this x, see this x? I pulled that out so that I could cancel. That got me going. All right, watch that through a couple times. Those were hard. Let me know if you have any questions. Hope you're having a great day. Bye-bye.